discovered that when I hit the live button, it didn't actually click live. And so I went to my YouTube page and saw nothing. I was like, what? We're live through Teams, and you're live through TikTok, but you're not live with the rest of the world. So I'm now live with the rest of the world.
Good.
And so that's good. But either way, I'll just refresh people's memories here and just say that. So we are live now. This is good. And it's a little bit late, I know, from when I said we'd go live. But we're here now, guys, and I hope you guys are going to join us tonight elsewhere in the world on YouTube and Kick and Rumble. We have some really cool stuff we're looking at. Hey, Tiffany Echo, and Renee Cruz, Bonnie Stanley. Good to see you, Michael Hedrick. Yay.
And we are live on my end as well. So
yes, I started live earlier on TikTok, but I haven't gone live with the mainstream until now. But that's okay because we got some great stuff to look at and show you.
I am live on my Trovo, TikTok, YouTube, Facebook, Rumble, Kick, Twitch, everything. So they have been tuning in. So I'm streaming to 7 platforms right now.
Okay, well then they're all pretty much everybody's seeing it. So
the gang is together now.
Yeah, the gang's all here. Well, anyway, guys, so check it out. Here we go. So now you'll see this here is the Whirlpool Nebula, the Whirlpool Galaxy that I was telling you about. But at the same time, I was also, with the other telescope, taking a beautiful image of the Orion complex. And I will show you that in just a second here. And here it is.
That's beautiful, though, what's on the screen.
I'll show you now. Is that. Yeah, this is gorgeous. And I want to show you now, watch this, as we move this to the left. All right. Notice all the dust. Now you see that blue color from that ionized oxygen I was telling you about before. This is all there now. Just stunning. I would like to say to the folks listening on TikTok, I don't have enough followers on TikTok to stream to TikTok, but I would like to. So if you can, just follow me on TikTok, that would be really helpful. Because then I can stream to TikTok, and I can't do that yet until you have 1,000 followers. I have this pitiful number, just a few, so that's so stupid. But all right, that's the way it is.
Sky Tour live stream. Look it up, TikTokers, and follow his channel. Those watching on my end.
Look at these details in here. We can zoom in, and I can show you. Look at the detail in here. All these convolutions and very intricate details. Look at this little, looks like a seahorse almost, this thing right here. It's a dark nebula. We call these dark nebulae because it's made of just dust. And this dust is actually backlit by the brightness of these nebulae here. Some of it is from glow, like this oxygen nebula, and some of it is from the red hydrogen glow of ionized hydrogen and the ionized oxygen. So look at the difference. This is fantastic. This black stuff, this dark stuff would never be seen unless we had something to contrast it against. See that? And I'll show you something down here. I'll do it. Let's see. This right here is good. If you look right down here, you'll see we have this light wispy structure right here. All right, let me zoom in on that. Okay. We have this light wispy structure, and behind it we see a red structure that comes up out of the wisp. See that? What that shows you is that this stuff here is in front of that red wisp behind it. It's in front of it. And that's what we see a lot in the universe, is stuff that is in front of other things, like this dust. This dust here is sitting in front of this part of the bright nebula, and it's blocking some of it. See that? This dust is sitting in front of that. Now, in front of this very, very bright area. This is the heart of the Orion Nebula, so there's a lot going on in here. Okay? Now, in the same way, this dust is common everywhere. It's common in many different galaxies. How do we know? Let's just look. Here we go. And now in here, let's zoom in on the Whirlpool galaxy, 23 million light years away. You can see in here dark dust, just like in our galaxy, a long line of it. Arcs
Yep.
of dark dust. This is what we have in our galaxy, the same kind of things. It seems to be concentrated in the spiral arms. The reason is because that's where the stars that are the hottest are born and die. And they liberate material to the universe, which makes lots of dust. And in their older, as they age, they actually will generate this dust as well in their outer atmospheres. So it's really kind of cool, you know.
Can
So
you zoom
this-
into that top portion, Mark?
To the what portion?
To the other one that
Up there?
went in. Yeah, that piece. Because it looks like you can actually see the stuff in front, what's in front and what's in behind, just in that image right there.
You can, because this stuff is in front, being
Exactly.
silhouetted by the brightness of this part of the galaxy.
Exactly. So,
Yeah.
like you said, commonplace.
Yeah, it is. Now I'm
That's
also I'm using a very high gain on this right now, so we have some noise in this image, but that's okay.
Yep. 23
I'm-
million light years away, and look how stunning it looks.
You're seeing this thing as it was 23 million years ago.
Yep.
Okay. So here is 5195 NGC, 5195 New General Catalog NGC. It's a galaxy in its own right. Then we have a Whirlpool Galaxy Messier 51 or NGC 5194. So these are a mixed pair, okay, a matched pair. So I'm going to call that the target, and I'm going to save it, okay. And we'll get rid of the annotation. Now that I'll save the image with the annotations.
All right, here comes
Now-
silly question number 2 from me. What is the oldest known recorded observed galaxy that we're aware of?
You have to. Let's qualify that. Oldest
Okay.
galaxy means how far away it is from our telescopes.
Correct.
But with
Not
an
years.
odd twist of fate, the galaxies that are the farthest away from us are actually the youngest. And that's because they are formed right after the universe began. And because they were formed right after the universe began, it took over 13 billion years for their light to get to us, okay? And that is something that means that the galaxy is very young. However, we're seeing it when it was young, but over billions of years, the light took to get to us. We ended up being quite. It ended up, of course, continuing to age, obviously.
Mhm.
So it's pretty cool.
That's amazing. Just thinking what you just said.
Yeah, it's pretty neat. But you see, there's a lot of incredible stuff in here, you know.
Mhm.
Yeah. All right. So I'm gonna save this one last time here, and save it exactly as seen. And now, why am I saying I'm saving it? Where am I saving it to, and what does that mean? Well, you see here, skytourlive.org. Well, if you go to skytourlive.org, you can also go to our data and see all these images yourself. In fact, you can download them and take them and check
I'm
them
going to
out.
pull your
Hang-
page up, Mark, and share it on my screen.
All right. Here's the
So they
Orion
can
Nebula
see
now
that.
on the other side. We're gonna do a final color correction here.
So for those watching on my stream, I'm going to share what he referenced to his page. It's skytourlive.com, skytourlive.org. If you go toward the bottom right here, you'll see go to the online database, and that's exactly what he just added to that database right there.
Well,
So
click
go
on
to
it
Sky
and show people the
I
photos.
can't
if you can
'cause-
do it.
I was having an issue when I was doing that, remember? I was
Okay.
opening up something else.
All right.
Michael asks, are there any unknown galaxies that haven't been named?
Oh, absolutely. The James Webb Space Telescope has just found more galaxies out there. In fact, it found the galaxy that was the furthest we've ever seen, and of course, we never knew it was there. So it's a brand new galaxy.
Wow.
Yeah, that stuff's happening. All right, so I'm going to come back here now, and I'm going to take us out of our low light mode, go back into our, I'm sorry, out of our deep sky mode, go back into our low light mode. All right. And in the low light mode, I'm thinking we're going to go look for something else. All right.
Okay.
So we're going to bring up our planetarium view that is linked. And what I'm going to do is I'm going to come out here and I'm going to move us up here.
And this is live, folks. Live from his observatory.
This is all live. That's right. Okay. So now we're going to come here and we're going to look at this galaxy. Now you might look and notice that, well, hey, look, here's the Big Dipper. And the other thing too, here's where we're looking now. And just below the tail of the Big Dipper is this galaxy, and just above the ladle of the Big Dipper is another set of galaxies we're going to look at. And just so you know, the Big Dipper isn't the constellation of a Big Dipper. It's the constellation of the Great Bear. And so here you see the Great Bear, okay, right there. And then if you follow the pointer stars here, it takes you to the Little Bear. How cute! And that's Ursa Minor.
Just so you know, we still see Orion. We're still seeing Orion on the screen.
Thank you so much. Yep. All right. So as I was saying, we were here, and we're going to go here.
Deep Sky Clock event.
Just below the tail of the Big Dipper is this galaxy where we are, and then just above the ladle of the Dipper is this next target we're going to go after. And so the Big Dipper is actually part of a bigger constellation called Ursa Major, or the Great Bear. Okay, so now that we're here, let's go and check it out. And you'll see the telescope swinging along a little bit.
Yeah, that's so cool.
Yeah.
Those are the
I think
stars.
it's kind of cool, considering that it's doing it from, 2,600 miles away.
He's sitting in his home in Connecticut, and this is happening from his home. He's remote controlling it. And it's, like you said, 2,600 miles away in Arizona. It's amazing.
Oh, yeah. Yeah. All right, let's see here now. Let me see if we can... All right, we're going to bring this into the center of our view now. There it is. Okay, this is called Messier 81, and it is a beautiful galaxy that is in here, and it's in Ursa Major, the constellation of the Great Bear. And we are going to come in and do another guiding setup here, get our guiding going, and make sure that we can. There we are. That should work. And now what I'll do is come out of here, and we're gonna make this a 25-second exposure as well. All right, and here we go. And then we're going to go into from our low light mode, we're going to go into our deep sky mode. And if our guiding is going well, we should be able to see the galaxy in just a few more seconds. You can see down here, we have the progress bar. It is hiding behind the Asterian Foundation sign. Our thanks to Asterian Foundation for giving us a wonderful grant, seed grant money to get some new equipment, which we're about to do. And so that's fantastic. And you saw one of Asterian's people in here before. That was Mike Toomey, who was actually in here earlier.
Yes. Yep.
Yeah, he's with Asterian. Okay, let's color correct. All right, and now let's look at this. So look at the size of this now. I'm not zoomed in on this. Well, I'm kind of sort of. You can see that's how much I'm zoomed in. Okay, but this is Messier 81, and this is a very different looking galaxy from the other one. This one's actually kind of on an angle, isn't it? sort of on a like a shallow angle to our camera. All right, and so we see this big extensive spiral arm going whipping around like that. We see these coming out and around, and they will actually resolve themselves and become even more clear in just a little while. Okay, as we do that, check that out.
I got a silly question for you from me. Do most, if not all, galaxies start out spiral and then something happens to change the galaxy
That's a
itself?
good that's a good question, because it's not a silly question. That's actually a fundamental question, actually, Bill. Galaxies. First of all, we got to address why spiral. Why a spiral at all? Why does it have a disk? Why is it a flat disk? Why isn't it just a big round blob? Okay. Well, we ask that question because there are galaxies that are just big round blobs. They're called elliptical galaxies, okay? And there are galaxies like that. But what happens is, and this is something that you learn in physics and that you understand when you see in space where things are falling toward a gravitational source, they will tend to make a disk. All right? It has to do with the way the particles are falling in toward the object. All right? They will tend to make a disk depending on their composition, really. So when we see a disk form in a galaxy, that's commonplace. So in many cases, the stuff will there'll be a nucleus, and many times at the center of these galaxies, what's living in here is actually a large supermassive black hole, what we call an SMBH. And a supermassive black hole is kind of like the seed that holds it all together, in effect. That's kind of where this comes from, you know? So I think that's pretty cool. You know. By the way, I do want to take a moment to say hi to David Schmidt. David, I'm glad you're here. We were worried about you with the problems over there in Thailand, because that's where David's living. And also want to say hi to Mary Ann, who was our guest on SkyTear Radio tonight.
Yep.
UAPPD. Yes, Bill finishing my sentence for me. Yeah. And then, of course, we have Kevin O'Neill. Hi there. Heinz Sherry's with us. And we've got a lot of people tonight. And it's so nice to see you all. Michael Hedrick, Renee Cruz, Roy Batty. Roy Batty's cool. Okay, Fantasy. And we have Donald Kunzer. Donald Kunzer actually had some really cool things to say in our radio show tonight. You know, Donald Kunzer's a smart guy. You know. And Tiffany Echo started us all off, and Bonnie Stanley's here, Daisy and Zoe. Stan from Two Rivers Observatory, that's TRO. Hi there, Stan. I did start the stream a little bit late, but it started on TikTok, and then I realized that the stream didn't take, and I just started it up, and here we go. So we have Messier 81 in telescope in Benson, and we have the Andromeda. We have the Orion Nebula in the telescope out in the Sonoran Desert. Color correct another time there. Here we go. There we go. Look at that. Wow.
Beautiful.
So you see the beautiful colors, and you see this dust. Really, see how it comes in? Looks so much cleaner, so much better than the first image we saw. You know? So much better. All right. So while we're waiting for this image to bring in more images, we have 11 stacked so far. You can see right there, it says 11 right there. So what we've done is we take one picture, we take another, align it with the first, and then stack it on top, and we build an image sandwich. That image sandwich will make it so that we see less and less and less noise. This is noise you're seeing in the image here. We're going to see less and less of it. All right? And that's what happens here. Now, all right, so I want to also, let's see here, as we let this thing come in, I'll do another color correction here. That's looking a little more like it. Like it should be. We got a little. I think there's a little too much blue in that. This should actually be more like this is pretty good. You see the blue spiral arms. The spiral arms of the galaxies typically are blue because that's young, hot stars, and young and hot means blue in astronomy and in the universe. Okay. So while that's cranking, I'm going to bring us back over to, we're going to go 220 miles away here. This is our live view. I'm going to actually just go to a 1 second view here. This is going to be our low light view. And now you'll notice in the middle here, you see that? That is what lights up the Orion Nebula. They'll zoom in on those. There's 4 stars in here. These are called the trapezium. These 4 stars are the lifeblood that ionize the gas that gives you the colors that you see in the Orion Nebula. And the slightest processing will blow it out. See that? So to capture all this faint stuff, you got to blow that out. All right? So that's how that works. So, that said, let's now go here. And let's go back to this. And we're actually very low to the horizon now with Orion. So it's not going to be very easy to see there anymore. Winter is kind of over, unfortunately. The moon is already up, but it's actually at a lesser phase. If I'm not missing my guess, yeah. Okay. Let me see one thing here. Okay, there we go. Yeah, I was wrong about the moon. I was just wondering why I saw it. I shouldn't have seen it yet. Okay. So now, let's go look at something that we can look at with this telescope that might be interesting. This is the Sonoran. There's Mars. In a wide field scope, Mars is a little orange dot. It doesn't look like much. Even in our scope, you know, over here, okay, with the more, well, that's beautiful. Starting to look really good. With the incredible magnification we have on this one, we still have to worry about the size of small objects. Like Mars is really tiny, so it's not very impressive, you know. So let's do this. Let's go. Actually, I think we can do. We'll do this here. I think we can do. And we're actually getting very low to the horizon here with that. All right. Well, here's what I'll do. I'm going to take us up to look at this cluster called the Beehive. This will be in our Sonoran telescope. You'll watch it. This thing move away here in just a minute right there. Yeah, I got you. Yeah. And you'll see now. You'll see the STLS indicator will show up here in just a second. All right, it lags behind, and here it comes. All right, and let's see. There it is, and there they are.
So cool.
This is the Beehive, and what I'm going to do is I'm going to kind of bring this down a little bit. I want to get this back into our view. Okay, here we go. So here's a cluster. This is a hot young cluster of stars. It may not be that young. It's actually, it might be a little older. I have to consult the details on this one to make sure. But this is a beautiful star cluster, and I'm processing it here. This is a processing thing I'm doing right now. I'm actually processing it, but it really would look like not quite like that, but it might look more like that in a pair of binoculars. Okay. All right. So we're gonna just come out of this here, and we're gonna go into our low light image. But I'm gonna take a 12-second shot. We don't have to take many seconds for this. Okay. And of course, we're running at extremely fast photographic speed. Okay. So now we have this. This is the Orion Nebula we took, and what we're going to see is the Beehive overlay in just a moment. There's the Beehive. Now we see that there's some wind, and we notice that the stars are elongated, so we're going to get rid of them. And let's see if the next one comes in. Yeah, we got wind right now. We're trying to guide. It's trying to guide, but the wind is actually making it hard. So let's see. That's okay. Yeah. You see the spider web in our building out there?
I
It's
see
dancing
that.
around.
Yeah, it's moving. Yeah.
Yeah.
The wind.
That may be oh, here comes the satellite. Look.
Yeah.
That may be a black widow web in there, but because we get lots of
Lovely.
black widows. Yeah. Oh no, they're fine.
You told me the same
Yeah,
thing
they're
about the
fine.
scorpion in the
Oh,
backyard
yeah.
too.
No, they're fine. You're right. They're just fine.
He goes out with the UV lamp and he's going around the perimeter of the property, and it's like,
Oh,
oh,
yeah.
there's one. Oh yeah.
Yeah. Cool.
Bill's favorite.
Yeah, they're neat. Okay, so this let me do this and just set the target name here. Save the image with that annotation on there. Yep. Michael Hedrick says it's just amazing to think how many worlds we're seeing in this view.
Absolutely.
I agree with that. I agree with that, Michael. That's a very prescient thing to say. Okay, and now we will save this and save it exactly as seen. And now, let's go to another one that is right nearby. And, oops, sorry. Okay, we're going to go and look at one more that's in this area. And that's this guy right here. All right, so we're going to move to that in just a second. And what I'm going to do first is I'm going to come out of our stacking low light, and I'm going to go into our, stacking deep sky, and go into our unstacking low light mode. So we can see this, and we'll see the frame here. That's the galaxy we just imaged. Okay. And I'm now going to have us come down to a little bit of a area. I'm going to center this up. Okay. And then say, go there. And you'll see this one move out of the view. Oh, wait a minute. You're not going to see anything move out of the view. There we go. All right. So I'm going to let that Beehive image come in, and let's see if we can get it without having too many problems with it. But meanwhile, this is the Cigar Galaxy. And we're going to let this build up a little bit. This one is pretty cool. And one of the problems we have is that telescope is really low, and it might actually be, I don't think it's impacting the, not impacting, but being blocked by the light, by the wall. But I'm gonna take us to a 10-second shot here. All right, let's do this again.
I'll never forget when you caught the meteor hitting the moon.
I know,
That
that was
was
pretty cool. Yeah. Okay, 20-second photo beginning with this galaxy, that faint patch of weirdness you saw in there. So now we're going to find out what that is. Okay, and what I want to do first is to have, I want to get the image and have it stack on something. Look at that.
Wow.
Yeah, that's really something. Okay, this is a galaxy that's very famous. It's called the Cigar Galaxy. I took pictures of this when I was, when I was actually getting my degree. Let's see if we can do this. Notice this. There's something interesting going on. This galaxy is seen kind of edge on. You'll notice all this red. That red is actually massive star formation regions. Because you know how the Orion Nebula, right, is very hot stars, hot young stars that are causing hydrogen to glow? Well, that's what we're seeing here. But across a major part of a galaxy, this is all nebula in a galaxy. Just imagine a galaxy like this that has mostly this nebula in it like this. Now, again, this is a galaxy that's about the same distance as the other one. Okay? All right, this one is, this is, looks like 12 million light years to the 23 of the other one. So this one's a little closer. A satellite just went through. Zing.
Yep.
Yeah. But at 12 million light years away, you're seeing it as it was 12 million years ago. So you got to wonder, you think about it. What was happening on Earth 12 million years ago? Right? That's when the light we see just now left that location. That's incredible.
Can we predict what that galaxy may look like in present tense? Do you know what I mean?
There's ways to model that. But what you'd have to do is have studies of neutral hydrogen in the galaxy, which allows us to calculate rotation rates and see which way gas is moving. And so we can actually project what a galaxy may look like in a million years. But we have to have those studies in place. Radial velocity studies. Galaxy rotation utilizes neutral hydrogen floating around that isn't ionized, just hydrogen gas that we can map and see which way it's going. See the details coming out now? Look at that. A lot of detail in here, yeah.
And the size, the scope is like how many light years across? Can we make a guesstimate how large it is? Yeah.
Well, I wrote a program to calculate, based on the size we see in the sky and knowing its distance, how big it is in actuality. So I guess I could run it through that at some point. I'm not now, but
the point is you can determine, you can make a guesstimate of what its size is.
It can be determined, yes.
Wow.
Yep. Yep. And Cosmic Ray rightly says that this galaxy has been affected by the one we just photographed. That's why it's got some kind of look you see here. Yes, go ahead.
In our Milky Way, what would be considered the closest exoplanet? How many light years? Do you know?
Well, the nearest planet to us is Alpha Centauri has Proxima, and Proxima Centauri has at least 2 planets.
And how many light years is that?
4.3.
Wow,
it's the
that is
closest
close
one
considering.
To us. Yeah. It is. Okay. And I've got this is M80. Let me catch it and then make that the target name. Okay. Save with annotations, and then so when I say save with annotations, this is what's going out there. That's the image that goes out there, and you can actually take that image. This is actually not in it. This is actually just overlaid. Okay. So this image is free to take at skytourlive.org. All the images we take are available to you. Okay, so now I'm going to just save this and save it exactly as seen. And then we're going to come out of here and move to the other side of the sky. Okay, so there we go. And we'll come out of here, get away from that. Okay, there's our... And here we go. So there is the Cigar Galaxy, as they call it. And now we're still facing north, looking at these things. So what I want to do is take us to a different location. Now we have over here, we have this image still coming in over here. And we'll keep that going for just a little bit of time. Let's make sure. All right. There we go. All right, now what I'd like to do, I'm noticing that some of the other astronomers on the mountain must be using their telescopes because our internet speed has slowed down considerably.
It's a beautiful night there. I mean,
yeah, we got away with it while we could,
makes
right?
sense.
Yeah. Well, that's okay. Let's come over here and let's come back here. And I want to take us up to something else. And I don't know that... Yeah, we're maybe not sure we're going to be able to see that. But what we can do is this. We can come over here and we can view something called the Leo Triplet. This is really pretty to see. And I believe, let me look at the altitude above the horizon, and I believe we can see it from here.
Now, we had a discussion. You and I had a discussion a few days ago, and you made it pretty much public today on SkyTour, the show on KGRA, about the grant. Now,
Yes.
How will that be beneficial to you as far as the equipment and some of the instruments that you can now upgrade for these telescopes?
Yeah, we're actually going to be thanks to Mike Toomey at Asterion Foundation and the grant that he awarded us. We're going to be able to get a system that will allow us to literally decipher the compositions of things we see in the night sky. Like when we look at this galaxy here, we were just looking at over here, okay? This galaxy has some emission in it, and this emission is this hydrogen that we see here, but there might be other things, right? And so what we're going to do is we're going to look at this galaxy in detail and get a spectral reading of it and see what other elements we can see in the spectrum of this galaxy. We can look inside a planetary nebula like the Ring Nebula or the Helix Nebula or the Dumbbell Nebula.
Wait.
So to detect...
Is it possible that you'll be able to, with this type of equipment, to detect the properties necessary for like an exoplanet and those conditions that would be sustainable for the possibility of life?
It depends on it. It depends. You need a very, very high resolution spectrograph to do that. We're going to have a nice resolution spectrograph. It won't be the very high resolution. The high resolution spectrographs are, $50,000 and up, and the one we're looking for is maybe $1,200 or $1,500, and maybe with all the additional pieces around $3,000, $4,000, $3,500 plus a camera. So we're getting some very, very important equipment from Asterion Foundation, and that equipment is going to allow us to make our way in the universe to other objects and decipher their compositions. And it doesn't mean that we can't do real science. We certainly can. As it is, we have an app that was written by Isabella Melamed, our Bulgarian super fan and super amazing person. And with that, you can go find every single time we took photographs of, say, this galaxy that we just looked at, and you can do comparisons to see if something changed in there. And we found things that have changed. There have been asteroids that came trickling through the field that we never saw. So stuff like that is really important.
Uh-huh.
You know? Yeah, let me look in here for a minute and see if I can. I don't think we have enough stars. Oh, we do have enough stars. Look at that.
Here comes another one of mine. If we were
Wow.
observing Europa, if we were with this type of spectrograph, would we be able to penetrate through the ice and see the properties underneath the ice sheet?
No, this isn't radar.
Okay. But would it still determine the chemical makeup, the elemental makeup?
It would see it might see ice.
The moon.
What are you talking about? Say that question again.
All right. So you said it'll be able to pick up elements.
Yes.
Okay. So when we're looking at Europa, for example, we'll be able to pick up the properties, the elements. But obviously, like you said, it's not like it's an underground or under ice array that can detect. It's like a radar. But we'll be able to get a good idea of the properties, the elements that make up the moon.
Well, I mean, it has light coming off of it, so we'll be able to look at the light that's bouncing off the ice.
Honestly, that's not what I'm talking about. So,
what?
No, I'm talking to somebody in the chat.
Oh, okay. All right, hold on. Let me try something here. All right, so let's do this now. Let's go back to this. And come back here.
Okay.
I wasn't sure what I was looking at there. Hamburger Galaxy, were we looking there? Yeah, I guess so. Alright. Let's see what happens. Let's do a 25-second shot. This doesn't look right to me, but I could be wrong.
What's up, Kathy? He's also streaming on his platforms as well.
Yes. Yeah, we're getting a significant amount of wind here.
Yeah.
So this may or may not give us what we want. And you see what's going on down here. Egads. Sorry about that. Just blew everybody out. 25 seconds. 250 and... Okay. Let me do it this way. And we'll see the result. If it comes in, this should be right now. Okay, so there are the two galaxies, yeah. Color correct this. Yeah. So these are the two galaxies. Now, this isn't our wide field system. Okay. Okay. If we do a identification here, M65 is here and M66 is here. Okay. And these are two of the galaxies in the Leo triplet. And there's another one. Actually, look at all the galaxies in this shot. There's tons of them here.
That's unbelievable.
Yeah. Every one of those galaxies has something to say. Now, I got to see if there's clouds overhead right now, because that looks kind of fuzzy right there. So let's see if I've got clouds in the northern. Oh gosh, look! I got
Yeah.
high altitude
Wow.
clouds here. No wonder this wasn't right.
Yeah.
Yeah, but down in Benson, it's still clear out there, so that's pretty good. So we'll actually we'll just come back here for a moment and let's look at something else.
So is
Wow.
this
Yeah.
now
Okay.
Benson?
What?
Is this the Benson telescope right now, or?
Yes, it is.
Okay.
Okay. There's just a major. I'm gonna spin this around here. There is Spica. And with this telescope, we should be able to see it up here, I think. Yeah. Every single thing you see here is a galaxy. Every little oval. Okay, and I'm gonna come in here. I'm gonna focus on this guy. Let's see if we can grab it. Okay, so we're going. And you'll watch the telescope move now. Okay, the telescope spinning the other way. And then we're going to have, or should have, a lot of galaxies in this view. Okay. So let's go see. Let's see if we can find them. I'm gonna stop guiding in this. And let's do this. Okay. Try to get this to accept my selection here. There we go. No, windy. Wind, look at the wind blowing this thing away.
I've actually seen that.
Yeah.
When you
the
were on
wind-
earlier with Marianne, she said it was quite windy there.
Yeah. Yep. That's what happens. On occasion, that's what happens. All right. So let's see if we can do a 25-second shot here. And go into our live stack. Huh?
It's windy here right now.
I believe it. And you're in Newburgh, New York.
And you ain't that
Let's
far
see.
either, so it might be windy by you.
Yeah, it might be. Yeah, I don't see the galaxies here, so I don't have the ability to. I don't have an all sky cam here yet, but I'm beginning to think that we might have some clouds that have made their way in. Because look at how much we have in Wickenburg. Yeah. Okay. Well, let me just go look at something and see.
Someone just asked me if there's northern lights in my area. Is there some kind of a CME?
Yeah, we got
that's-
a. Yeah.
Yeah?
There was a CME. Yeah. Okay, we're We do have some light clouds here.
All right, I'm gonna peek outside my door just out of curiosity.
Yeah.
See what's actually going on.
I'm looking in the all sky here. We actually had north is up here. Notice the compass rose north, south, east, and west. We had auroras all up in here and to the north when we had that last coronal mass ejection. Really, really fun stuff. Okay, let me.
Not that I can see.
Yeah.
Nothing visible here.
Okay, good. So I'm. It knows where I am, so I'm going to do this. I'm going to check that. That's where I want to be. Okay, we got a few things to look at here. Let's see if we're actually in trouble here with with this. What?
So these thin clouds are in both locations right now?
I'm hoping not. I'm about to find out.
Okay, because I just stepped out to see if I'd seen anything outside, but it's probably way up north.
Well,
You
you
had
can
it
look at the
too.
auroral oval online.
Yeah, space
Okay,
weather.
I'm actually I'm re-syncing with everything to make sure that I can see what we want. Yeah, okay, let's do this again.
They are saying it that there is a possibility tonight.
Oh, really?
Mm-hmm.
Wow.
It said your Earth magnetic field is reverberating from the impact of a countable CME on April 15th.
Yeah.
Geomagnetic levels are currently ranging from G2 moderate to G3 strong. If this activity persists at current levels, auroras could appear across Canada and some northern tier U.S. states during the night of April 16th and 17th.
Wow.
Yeah.
Oh. My mistake. I did something silly.
But it's way up to the north. It's nothing close right now. I'm looking at it
so
right now.
you can see the auroral oval.
Yeah. It's way up north.
Okay. Okay. All right. Let's get rid of that and this should have been. All right. I want to just check out where we think we are. Markarian's chain. We should see that and the eyes down there. Yep.
We're looking at the all sky right now on screen.
Yeah. Let me just. I was working with. Try to get this working. So.
Oh, okay.
Okay. So let's do this now. Let's move this up there, and let's move it over. Okay, we're gonna move this up right about there, and I get this centered up a little bit. Okay, galaxies tend to be faint, guys, but we're gonna try here. We're gonna see if we have light clouds or not, because I'm gonna do a 25-second shot, and it should be pretty clear. But it looked like we've had clouds in some of these other shots. And sometimes what happens after the sun goes down, the desert releases its heat, and you actually get a high bank of clouds for a period of time. And they disappear later on in the evening, for sure. All right, let's see if we get our... I'll dock that up right now. When we didn't have any clouds earlier, it was actually looking pretty beautiful. Wait a minute, let me just get rid of this. Yeah, okay. Yeah, these streaks here, these are indicative of clouds. Unfortunately. There's a beautiful galaxy there. Let's see if we can identify them. Yeah, measure 86, yeah. Okay. Hey, Sarge. Sarge says hi. Daryl's not with us tonight, Sarge. Daryl's not feeling well. And that's Bill, New York Skywatcher, who is on with us right now. Unless he's fallen asleep.
Oh, I'm here. I do have station duties to attend to soon, though.
Yeah. That's okay, because,
Clouds.
with clouds like we see here,
Yeah.
and the clouds that we see apparently in here, it's sort of crippling our view. You saw how beautiful the Whirlpool looked before. That's yeah, we're getting see this haze.
That's indicative of those lines going across, right?
Yeah, there's cloud haze that we're seeing.
Yep.
Yeah, unfortunately, that's okay. We had some really nice objects to look at anyway.
Mm-hmm.
Let me do
The
that.
Orion were stunning earlier.
Oh, beautiful, yeah. Yeah. You get a lot of this modeling in the cloud data that when you see this, so yeah, let me turn this off and see if it makes a difference. A little bit. Yeah, see, and you'll notice, well, we're not able to stack our frames, and that's because it's having trouble identifying stars because they're coming and going. Let me make sure this is going. You know, this guider isn't even able to stay on the guide star. Okay, well, that pretty much tells me it was a good night. It was a good night.
It was.
And I would like I say, I really would hope that those of you on TikTok will, go to my TikTok and follow me there so that I can get to 1,000 and I can stream into TikTok as well.
So for those on my TikTok, go to Sky Tour live stream. It's all one word. You can search it. Even simply Sky Tour on TikTok, and you'll find his channel. And follow it. This way he can build up, like he just mentioned, 1,000 followers. This way he can go live to TikTok.
Yeah, we can start spreading the word, man. This is great. Again, I want to thank Mike Toomey of Asterion Foundation for helping us out with what we're doing. We're going to move into the next phase of what Sky Tour is all about. Thanks to the organization and the foundation he's part of. And it's funny because there's a lot of organizations that are pretty high end that support them and support Asterion, including some really prestigious museums of natural history in New Mexico, the International Dark Sky Association, Lowell Observatory in Flagstaff. So we have, and everybody there had to sign off on what we do to supply us with this grant. And so you can't imagine how ecstatic we are that they saw the value in what we do. But that's specific money for a specific tool, and that's the spectrograph that's going to go on a telescope that has yet to be determined. We don't have a telescope for that yet. We do. I mean, I have one behind me that we may use for this. But we also have some potential donations of a larger telescope, not larger than what we've got, but telescopes that can allow us to actually put this spectrograph on it and start acquiring spectra. It's going to be a dedicated instrument just for that. Then in the front here, I'm in Connecticut. I'm putting a solar telescope, which I already have. I'm putting a solar telescope in the front here.
Yep. Where the old one was at one point.
Yeah, where the old dome was.
Yeah.
The dome that I was telling the story before. Some of you heard, but before I was streaming, I put a dome on the front lawn, and it became the talk of the town. Everybody would drive by and say, "What's that?" They'd stop, take pictures, stare at it. So I took advantage of it. When it was Halloween, I dressed it up like Stuart the Minion. Big giant eye, coveralls, yellow. Yeah.
Yeah, that was pretty cool. I was inside of it. It was nice.
People liked it. Yeah. So, but I sold the dome because we grew out of it, and the next thing I'm gonna get now is I'm gonna get a much smaller container that's gonna hold the solar telescope. Of course, it'll be all fully remote. I'll run it from here, and the cover will open up and allow the telescope to see the sky, and there'll be a dedicated solar mount on it. When you turn on the mount, it finds the sun and lines up the telescope on the sun, and that's what we're looking for.
And also, thanks to what Marianne and Tara do as well.
Of course, yeah, Marianne and Tara are the ones that were the movers and shakers to get this telescope in place, and to get this telescope in place. Okay. I built the all-sky cam, which is kind of cool. I found out a way to build the all-sky cam, and it really came out beautiful. And so you see all this data. This is from Thomas Jaquin's all-sky. See right now it says the moon elevation is minus 16 degrees above the horizon, so it's minus 16. It'll come up eventually. But you see the brightness over here. This brightness is because we're getting some moon glow already, and that's part of the problem.
Yep, combination on these thin clouds.
Yeah.
Well, Mark, thank you for sharing your content on my end, and to your viewers, have a great morning, great night, and we'll do this again soon. Actually, when the moon, when there's no light pollution from the moon specifically, but on a clear night,
you can see it's getting worse. You can see the moon. The moon glow is starting to show up more and more and more. The moon is right there. It's almost there. Okay. Well, guys, you guys have a good night. We're gonna go. And Bill, thank you so much for coming on and hanging out.
Yep. Have a great night.
Thank you so much for streaming us to TikTok. Make sure that if you haven't yet, subscribe to us. Subscribe on our YouTube channel, and follow me on TikTok so that you can help me get to that magical number 1,000, so we can actually do more of what we do. Again, 2 telescopes, soon to be 3, and then 4 for the spectrograph. So we got a lot happening. I'm telling you, we have to create a whole new internet for this. Wow.
All right, that's Mark. Okay. Have a great night.
All right,
and
guys.
We'll be in touch.
All right, guys. Have a good evening, and I will talk to you soon. Good night, everybody.
Later, Mark.
Later, bud. I'll talk to you later, Bill.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every night feels brand new.
Telescope disconnected.